last lecture. Now let's see the next thing, that is directory, right? So what is this directory? So we know that we store files in directories. So, but actually logically, what is happening? Physically, we are seeing that there is one folder in which the files are there. So physically, your directory that can be viewed as a symbol table that translate your file names into their directory entries. So it's one kind of table which store your file name, in entry. Actually, it's store your inode as well, right? And use of this inode, because that is uniquely identified, and then using that inode it will search in different directory, right? So it's just one kind of table which stores the entry of your file. Okay, or it can be a directory as well, because in directory we can have another directory as well, so that is possible. Okay. And which are the operation that you can perform with the directory? So what you want from directory? We should be able to search for a file, right? So that must be possible. We can search in this directory. We can create a file in this directory. That should be possible. Then delete a file. So basically when you create file, what happen? It will make an entry in your table. When you delete a file, what will happen? The entry will be deleted from the directory. So then you cannot search, right? Then you can list a directory. We have used the command ls. It lists all the files and directory available in that directory. So it can be list a directory. It can rename a file. So these are some of the operation that can be uh, performed on directory. Uh, now, how this directory or directory structure is, how this look like? So the logical structure, right? If I say logical structure of directory, right? So different ways are there. This way you can organize your directory, right? So first is single level directory. Single level directory. Okay. So in this, what happened that this is your single directory, and in all that we have one file. This is your file. This is your file. Likewise, right? And this is your directory. So here you can create a multiple directory. In that you have one file. So what is advantage in this, right? Basically जो भी फर्स्ट एल्गोरिथम या फर्स्ट मेथड देखोगे आप किसी में भी, एक एडवांटेज तो आप लिख ही सकते हो. कौन सा? सिंपल टू इम्प्लीमेंट, राइट? सिंपल टू इम्प्लीमेंट किसी में भी मोस्टली फर्स्ट मेथड होगी, टेक्निक एल्गोरिथम, ये एडवांटेज आप इजीली लिख सकते हो. एंड सिंपल टू मैनेज, क्योंकि एक ही डायरेक्टरी एक ही फाइल है तो वो इजी रहेगा. ओके. ड्रॉबैक्स, as this is a single directory, there is a name conflict. Name conflict may arise here, right? So there can be a name conflict. तो आप सेम नाम देना हो तो आप नहीं दे सकते हो, right? So there is a name conflict, and in this आप देखो सभी फाइल यहाँ पे है, so searching time that will also increase, क्योंकि सर्च करना वो भी हमें नहीं पता है, so that will also increase. So name conflict and searching time, that will be increase. So these are the advantage. So to overcome this, what we have two level directory structure. What we have? Two level directory. We have two level directory. So इसमें क्या होगा टू लेवल डायरेक्टरी में? जस्ट वेट. Hello. 185. You are yes. Okay. So we were discussing about single level directory, and then we move to two level directory. So in this two level directory structure, it is like this. We have this master file directory. In that we have directory for different user 2, 3, likewise, and in that we have a user file directory, UFD, you can consider, right? So that is under that user, and here we have individual file, you can consider, right? So this user wise, right, because all your files are here, you can consider that this, right? So in two level directory we have resolved that your name conflict now, right? So we have resolved that thing. But what is disadvantage? एडवांटेज तो एक पता चला कि ये नेम कन्फ्लिक्ट हो रहा था, वो यहाँ पे नहीं होगा, राइट? एंड आइसोलेशन फ्रॉम अदर यूजर्स, बिकॉज ये एक यूज़र वन की डायरेक्टरी है, सो आइसोलेशन. और ड्रॉबैक डिसएडवांटेज क्या होगा इसमें? एज दिस प्रोवाइड्स आइसोलेशन, ये आइसोलेशन प्रोवाइड कर रहा है, सो द कम्युनिकेशन बिटवीन यूजर्स, राइट, फाइल शेयरिंग एंड ऑल, that is difficult, right? So sharing of files, that is not possible due to this isolation. Okay, The next is so this is two-level directory structure. Then we have a tree structure. So the manner that you have created tree, the same way you can have multiple directories, right? This is a two-level directory only, but I can have 3-level, 4-level, right? So multiple directories I can create. Okay, so here you can consider you have a root directory. Under that you have different directory like lib or temporary, right, home. These are the different directory available. In that you have some another directory. Under home you may have different users, right? So this way it will go. But here in this tree structure, what will happen? The sharing is, you can see here, still it's difficult. What we have increased, we have increased the depth here. We have increased the depth here. Okay, so still the sharing is difficult. And suppose I have created some name over here and same name over here. You can create that thing. So this is a tree structure, and when you create a duplicate entries, it will like wastage of space, you can consider. And that will, if it is a duplicate, suppose say I have created same data and same file over here, right? And as this is not a shared, दो फाइल है, एक यहाँ पे और यहाँ पे है, दोनों अलग अलग है, राइट? shared नहीं है. अब क्या होगा? सपोज आई एम अपडेटिंग 10, तो आइडियली सेम है तो क्या होना चाहिए? ये अपडेट कर रहा हूँ तो यहाँ पे भी वो सेम कॉपी होनी चाहिए, सेम कॉपी, राइट? जो भी यहाँ पे अपडेट की यहाँ पे होनी चाहिए. बट वो पॉसिबल नहीं होगा, राइट? सो दिस विल लीड टू इनकंसिस्टेंसी ऑफ डेटा. राइट? सो दो कॉपी बनाने की ज़रूरत नहीं है. सपोज टैम्प में वो फाइल चाहिए, मैंने कॉपी बना के उसको वहाँ पे रख दी, एंड टैम्प भी एक्सेस करा है, लिब यहाँ पे एक्सेस करा है, कुछ अपडेट करूँ मैं यहाँ पे डालूँ. सो दिस इज़ नॉट अ गुड सॉल्यूशन. So the one that we need to use is directed acyclic graph directory structure, right? So this is, you can say, extension of this tree structure, only. But now here the advantage is the file sharing is possible now, right? Because suppose this is your tree, now under root you have this directory, you have some another directory over here, यहाँ पे भी कोई directory है, यहाँ पे भी और directory है, suppose यहाँ पे एक file है ये, right? This is the file under this directory. अब suppose यहाँ पे जो कोई user है, एक और directory ले लो, उसको ये file same चाहिए, so they can share this. And suppose यहाँ पे भी कोई और एक directory है, उसको भी ये चाहिए, so they can share. So now sharing is easy in this. But here you need to maintain the count of that file. कि ये फाइल अब जो है ये इसने भी ओपन की है, सपोज यहाँ पे भी ओपन हुई है, यहाँ पे भी ओपन हुई है, right? So you need to maintain that, and you need to maintain link count as well. कि वो किसके साथ connected है. But now sharing, name conflict, all the things we have resolved. All the things are resolved now in directory structure, directed acyclic graph. Okay, so these are the directory structures that we have seen: single level, two level, tree structure, or you can say multi-level or hierarchical, whatever you want to say. So these are the directory structure. Now next is, let me check. Okay, so protection of files. So how you can protect the files? Protection of files. So how you can protect your file, right? So you want that I want to give access to some users, not to all users. So this way we want to protect our files कि कौन सा रीड कर सकता है यूजर, कौन सा राइट कर सकता है, कौन एग्जीक्यूट कर सकता है. So one simple approach is access control list, ACL, access control list. So with every file you attach this access control list, right? What it maintains for each user what is the permission for that file. Suppose for test.c, this is my file, and now what I will do for user 1, what is the permission, for user 2 what is the permission, for user 3 what is the permission. This way I will maintain the permission for all the users, right? So suppose user 1 रीड परमिशन राइट परमिशन देनी है, यूजर 2 को रीड देनी है, यूजर 3 को रीड राइट एक्सिक्यूट सभी परमिशन देनी है, right? So this way I can have access control list that is attached to each file. Now what is the disadvantage over here? As number of user increases, the list is going to be increased, so that is one tedious task. Another thing is, suppose for all user you want to give read permission, then that you need to change for all the users, सबके लिए वहाँ पे change करना है, और वो भी एक tedious task बन जाएगा. So what they think of, rather than this, make a group, and you are aware about this: user, group, and other, or universal, right? So categorize the user in this: user, group, or other. Once you categorize in this, then you have 3 bits associated with each group or each classification. You can give permission: read, write, execute, read, write, execute, read, write, execute, right? So the users belong to this will get this permission. The users belong to this class will get this permission. User belong to this will get this permission, right? So now your task is easy, and this we have seen, right, in practical as well, how we can change using chmod. This command we have used. Okay, so this thing we are aware about it. Next is, okay, so this is over. Now next we'll see the implementing this file system. Implementing file system. Okay, so how you can store your file? How we can store the file? So the disk, right? We usually use disk to store our file. And what is the reason behind that? Why we use the disk is the characteristic of disk, right? I'm talking about hard disk. So it can be easily rewritten, right? Wherever place we want to rewritten, it is easily possible, right? And it is possible to read a block from the disk, modify the block and write it back into the same place. That is possible. Then it can access directly any block, right? It can access any block directly, right? And this way it will make it very easy to access your data. Just you need to um, set the read write head and your circular movement of the disk, right? The detailed architecture of your hard disk that we are going to see. Okay, but right now just remember this thing. So whenever you read data or write data, it is in terms of block, right? So it can read whole block or write whole block, and block may consist multiple sectors, right? And ideal block size is 512 bytes. 512 bytes. So now the file system, it provide an efficient and convenient access to the disk by allowing data to be stored, located and retrieved easily. This is the use of your file system, right? It should provide efficient and convenient access to the disk, efficient and convenient to the disk by allowing data to be stored, located and retrieved easily. राइट आपने स्टोर कर दिया, रिट्राइव करने में ज़्यादा टाइम ले रहा है. There is no use of such storage mechanism. Okay. So now this storage medium जो हमने अभी बात की, they may face some problem, right? First problem is how the file system should look to the user, right? And this involve defining a file, its attribute, right? The operation that we are allowed on file, the directory structure, the organizing file. So this must be decided, and to decide this is a problem. We cannot say problem, but we need to define this thing if you are going to implement this file system, right? And the second challenging task is creating algorithms and data structure for what? To map the logical file system onto the physical storage, that is your hard disk. File system हमने बना लिया, right? Logical, like we are creating file and all, logically हमें मिल रहा है, दिख रहा है, but ultimately this thing we want to store on hard disk. Permanent storage में हमें store करना है, right? उसके लिए तो हम ये use कर रहे हैं file system and all, right? So for this we require or need to create algorithms for this. So this is also a challenging task while you implementing file system. Okay, so it's just one kind of logical view file system. क्या आपके आई थिंक मैंने लास्ट टाइम डिस्कस किया था कि डेटा आपका हार्ड डिस्क में है, डेटा कैसे रिट्राइव करना है, यूजर को कैसे देना है, that all depends on this file system, right? So this file system may contain information about how to boot an operating system, क्योंकि वो भी चाहिए हमें, क्योंकि पहले पता नहीं होगा कि ऑपरेट एट एनी स्टार्टिंग पॉइंट व्हाट यू वांट टू फर्स्ट लोड योर ऑपरेटिंग सिस्टम, तो वो कहाँ से आएगा? हार्ड डिस्क में से आएगा, राइट? the total number of blocks that you want or that you have, वो हमें पता चलना चाहिए, and the number of free blocks and location of those free blocks, वो हमें पता होना चाहिए, right? And the directory structure, individual files, okay, this thing we should know. Now there are some terminology associated with this. Let me write this. One is boot control block. Boot control block, right? So this will contain the information needed by the system to boot an operating system from the volume, or you can say partition. And if the disk does not contain an operating system, then this block is empty. Then this block is empty. And most of the time, this is the first block of your storage. ये जो boot control block होगा, वो first block होगा most of the time, right? So that's why when you boot your system, तो पता चलेगा जब मैं लोड करूँगा तो कि मुझे कहाँ से वो लेना है कोड, right, to run my operating system. Otherwise you need to pass the address, प्रॉपर एड्रेस पास करना पड़ेगा, वो एड्रेस आपको कहीं कहीं पे स्टोर करना पड़ेगा, right? And that you need to take. And there are different terminology for this boot control block. Sometimes in like UFS and all file system, they refer this as a boot block. In NTFS, they refer this as a partition boot sector. Yes, partition boot sector, right? The second is a volume control block. Volume control block, or you can say partition control block. Okay, so what this store, it will have a details such as the number of blocks in this partition, the size of the blocks, free blocks count, free block location, and the pointer of this location. So this free block count must be there, because when you create a file, your file require free blocks, right? So free block count and all the pointer to the free block count is required. And in UFS, this is called a super block. And in NTFS, I think it's a master file table, right, which contains this information for any partition, for particular partition or volume, right? कौन सी information, number of blocks in the partition, block की size क्या है, कितने block free है, right? Free block का pointer means कहाँ पे free है. So this information will be stored in volume control block. In UFS it is referred as a super block, and in NTFS it is referred as master file table, right? Then directory structure, right? Directory structure क्या है? Directory structure, right? So what is the directory structure? Is used to organize these files. So this thing is required. Then per file, your free block pointer that you require, and it has a detail about your files, right? So your file control block, with every file we have a file control block. So this file control block will store all other, you can say, attribute or file related information in this file control block. So that is also associated. So this thing, let me write this, file control block. Okay, so this thing is required. And in file control block, if I say the typical information that are stored is, one is file permission, second is file dates, means it includes created date, then modified date, access date. These dates can be stored. Then your file owner group, or you can have ACL list as well. Then size of file, उसकी size क्या है in terms of blocks, right? And data blocks pointed to this data blocks, ये सब information यहाँ पे रहेगी. And file is uniquely identified by that inode number, So there are two terms associated when you create a file or other data structure. One is system-wide open file table. System-wide open file table. It contains copy of your FCB, right? File control block of each open file and other relevant information, means कितनी बार ओपन हुआ वो सब, वो किसमें कन्वर्ट होगा? ओपन फाइल टेबल. बट दैट ओपन फाइल टेबल इज सिस्टम वाइड, पूरी सिस्टम में एक होगा वो. देन नेक्स्ट इज पर प्रोसेस ओपन फाइल टेबल. पर प्रोसेस, right? It contains a pointer to the appropriate entry in the system-wide open file table, right? So एक system-wide file table है, open file table, यहाँ पे per process wise file table है. So कोई एक फाइल है ओपन होगी तो FCB फाइल कंट्रोल ब्लॉक और अदर रिलेवेंट इंफॉर्मेशन विल बी स्टोर्ड. और जो भी प्रोसेस यहाँ पे ओपन करेगी, राइट, पर प्रोसेस ओपन फाइल टेबल्स, दिस कंटेन्स द अप्रोप्रिएट एंट्री. यहाँ पे जो भी अप्रोप्रिएट एंट्री होगी वो एंट्री यहाँ पे पॉइंट करेगी, राइट. सपोज द सेम फाइल अनदर प्रोसेस इज ओपनिंग, दूसरी भी प्रोसेस वो ओपन कर रही है, तो इट विल पॉइंट टू द same file and just count will be incremented. Count increment होगा. This is system wide. This is per process. Okay, so when you create a file, your application programs, it will calls the logical file system, and the logical file system knows the format of the directory structure क्योंकि वो हमने स्टोर किया है. And to create a new file, it allocates a new what file control block, क्योंकि उसमें हमें ये information स्टोर करनी है, right? So it will allocate that. The system then reads the appropriate directory into memory, क्योंकि इसकी appropriate directory कहाँ पे create हुई है, that I need to read because वहाँ पे मुझे entry भी करनी है. Okay, and update it with the new file name and your file control block. और फाइल कंट्रोल ब्लॉक में भी अपडेट करनी है. नाउ ये तो लॉजिकल हो गया, एक्चुअल मुझे स्टोर भी करना है. सो देन आई विल राइट इट बैक टू द डिस्क. वो मैं डिस्क में भी राइट करूँगा, राइट? क्योंकि जब क्रिएट होगी फाइल, कुछ लिखूंगा तो ब्लॉक जो असाइन हो गए, राइट, दैट थिंग विल बी हियर, वो सब अलोकेट होगी. Okay, so this way you can create a file or allocation ऐसे होगा. Any doubt in this? Okay, now suppose when process close the file, प्रोसेस ने जो फाइल क्लोज कर दी, तो क्या होगा? पर प्रोसेस टेबल एंट्री जो होगी वो रिमूव होगी. per process जो एंट्री होगी वो रिमूव होगी, राइट. मीन्स ये जो लिंक है वो रिमूव होगी, एंड यहाँ पे जो काउंट है वो काउंट क्या होगा, वो डिक्रीमेंट होगा. दिस विल बिकम 1. And when all user that have the open the file and close it, और यहाँ पे भी कुछ अपडेट है फाइल में, सो वो कॉपी फिर से कहाँ पे स्टोर होगी, इन योर हार्ड डिस्क, in your hard disk, right? That will be stored in your hard disk. Okay, now when you attach a pen drive to your system, तो क्या होता है, your pen drive has also a structure, directory structure. So क्या होगा, when you attach your pen drive, that directory, right, your USB, that directory mounts to your operating system directory. वो यहाँ पे माउंट होगी, राइट, कहीं पे वो माउंट होगी. आफ्टर यू माउंट इट देन यू कैन एक्सेस योर डेटा. माउंट होने के बाद, राइट, वंस योर टास्क इज ओवर, व्हाट यू अनमाउंट इट. मीन्स आपकी जो डायरेक्टरी है ऑपरेटिंग सिस्टम से, वहाँ से आप डिटैच कर रहे हो, उसको अनमाउंट कर रहे हो. So after that I cannot access that. कई बार you encounter that corrupt हो गया है, नहीं चल रहा है, तो वो क्या हुआ होगा. corrupt means जो आपका अंदर डेटा है उसके बिट्स में भी चेंज हो गए हो, राइट. वहाँ पे इंफॉर्मेशन 10 में स्टोर हो रही है, और कोई मैग्नेटिक फील्ड उसके कांटेक्ट में आए तो इंफॉर्मेशन चेंज हो सकती है. वो 1001 वो चेंज हो सकता है, राइट. और वो चेंज हो गया मीन्स जो हम रिट्राइव कर रहे हैं डेटा, जो हमें फॉर्मेट पता है उसमें हम रिट्राइव कर रहे हैं, तो वो डेटा प्रॉपर्ली रिट्राइव नहीं हो रहा है, राइट. योर फाइल सिस्टम दैट कुड नॉट अंडरस्टैंड दैट थिंग, वो अंडरस्टैंड नहीं कर रहा है, इसलिए फिर वो एरर देता है, राइट. उसके बाद वो एरर देता है. ओके, एंड दिस इन पर प्रोसेस ओपन फाइल टेबल व्हाट यू हैव, फर्स्ट 3 एंट्री जो होगी वो रिजर्व है, नंबर 0 1 2. दिस इज कॉल्ड अ फाइल डिस्क्रिप्टर. यहाँ पे जो भी होगा इंडेक्स, दैट इज अ फाइल डिस्क्रिप्टर. फाइल डिस्क्रिप्टर है 0 1 and 2, that is reserved. Reserved for what? Reserved for read, write and error message. Read, write and error message. Okay. Okay, so we have seen the directory structure, then implementing the file system, then file control block, वो सब हमने देखा है, like system wide open file table, per process open file table. Now directory implementation, your directory implementation. So the selection of directory allocation and directory management algorithm, right, it will affect the efficiency, performance and reliability of your file system. कि directory का जो allocation है and how you manage the directory, right, it will affect that what efficiency, performance and reliability of your file system. Okay, so the directory can be stored. One is linear list, right? This way you can store कि सभी एंट्री डायरेक्टरी के है वो मैं linearly स्टोर कर रहा हूँ, एक ही पूरा लिस्ट बना रहा हूँ. Okay, so this is the simple method to implement, right, and it is used to store in linear list, right, and it will store the file name and pointer to the data block. But now what happened here, as this is simple to implement, but to search a directory, it's a tedious task, क्योंकि पूरा लिस्ट मुझे सर्च करना पड़ेगा, right? Another is hash table. With every directory or file, as I said, I know this associated means some number is associated. So I can use a hash table, the hash function. So hash function generally क्या करेगा? Suppose this is my hash function, ये है, यहाँ पे जो भी नंबर आएगा मॉड्यूलो 64 करूँगा, तो जो रिमाइंडर बचेगा, वो ब्लॉक में ये डायरेक्टरी मुझे सर्च करनी है. तो मेरे पास कितने ब्लॉक हो गए? 64 मीन्स 0 to 63 ब्लॉक होंगे. नंबर आया मॉड्यूलो 64, राइट. इफ इट इज 65 मॉड्यूलो 64, तो आंसर है 1. तो 1 वाले ब्लॉक में वो मुझे सर्च करना है, 1 वाले ब्लॉक में सर्च करना है. बट हियर डिसएडवांटेज इज द साइज इज फिक्स्ड. बट ऐसा तो नहीं है कि डायरेक्टरी, नंबर ऑफ डायरेक्टरी फिक्स है कि इतनी डायरेक्टरी में क्रिएट करूँगा, उसके बाद डायरेक्टरी नहीं क्रिएट करूँगा. नो. सो दिस इज़ नॉट अ गुड सॉल्यूशन. क्योंकि 64 तक बराबर दे रहा है, 65 आया तो वो 1 में डाल रहा है, राइट. सो इंस्टेड ऑफ दिस, what can be done? The alternative solution is chain overflow hash table. So in this, what will happen, that this hash table is there, but the entry in that hash table, that is a linked list. This is a linked list. So 1 modulo 64, answer is 1. So 1 I will search over here. If my next block is 65, then 65 modulo 64. So the answer is 1. So in that, I will store like this. Right? So 1 and 65. So whenever you need to search the directory, yes, someone is asking something. 72 Raj.
Yes, sir.
Yes, any doubt?
No, sir. Sudden some wrong number came up, and so that why my mic was left on mute.
Okay. So now you can see here, when you have some number, you perform modulo operation, then you have restricted your linear search. Means अब आप पूरा लिस्ट सर्च नहीं करोगे, बट नाउ यू विल सर्च इन दिस ओनली. इसमें ही सर्च करोगे, राइट. अब जितने भी आए, सपोज 1 लाख है, कुछ भी आए, मुझे क्या करना है? मॉड्यूलो परफॉर्म करना है. जो नंबर आएगा वो पूरा लिंक लिस्ट करेगा, उसमें पूरा लिंक लिस्ट होगा. आई नीड टू सर्च इन दैट ओनली. मुझे इसमें ही सर्च करना है, right? So we have reduced the search. So this is chain overflow hash table. This is the chain overflow hash table. Any doubt in this? So directory implementation, 3 things we have seen. One is linear list, second is hash table, and third is chain overflow hash table. In this portion, I am covering from the book Galvin, right? Operating System Concepts by Galvin. दो जो टेक्स्ट बुक बोली है आपको, एंड्रू एस टेनेनबॉम एंड गैल्विन. तो अभी जो फाइल सिस्टम का चल रहा है, दैट इज फ्रॉम गैल्विन.